Welcome to The Explainer. So today we're going to dig into why those huge wildfires and droughts you see on the news, well, they might not be the real story when it comes to forest collapse. New science is telling us the biggest threat is something much quieter and a whole lot more complex.
We all see the dramatic headlines, right? Massive wildfires, record-breaking droughts, giant insect outbreaks. But what if those shocking events are just the final chapter, the visible symptom of a problem that's been building up for a long time? Well, this new research shows that's exactly what's happening.
So here's the thing. The real danger isn't always that single, loud event. It's the quiet, connected series of events leading up to it. It's a hidden chain reaction where one problem creates the perfect conditions for the next one, and then the next.
All right, so to really get our heads around this, we first need to look at the individual players in this whole drama. These are the forces that, even on their own, can cause some serious damage. Ecologists have been studying these 5 major disturbances forever. You've got your usual suspects: drought, wildfire, huge windstorms, insect outbreaks like bark beetles, and of course diseases from pathogens. But here's the key. Historically, scientists have mostly studied them one at a time, in isolation.
And, we do the same thing. We see a news report about a drought one year, then a fire the next, and we think of them as two totally separate disasters. But that way of thinking, it completely misses the bigger and, frankly, much scarier picture of how these forces can team up against a forest.
So how do these threats actually build on each other? Well, this new research gives us a framework to understand these team-ups. They call them interacting disturbances, and this idea is at the very heart of this story. It's a pretty simple idea, really, but the consequences are massive. One event doesn't just happen and then it's over. No, it can actually prime the entire ecosystem, basically setting the stage for a second event and making its impact way, way worse than it would have been by itself.
This slide, it lays out the perfect recipe for disaster. Let's just walk through it. Step 1, a bad drought comes through and stresses out all the trees, weakening their natural defenses. Step 2, because they're weak, those trees can't fight off bark beetles, which just sweep in and kill them by the millions. And then, step 3, you're left with a forest full of dead, tinder-dry trees, just perfect kindling for a truly catastrophic wildfire. It's a devastating 1-2-3 punch.
And this is absolutely crucial. We're not talking about simple addition here, like A plus B equals a slightly bigger problem. In a lot of these cases, the interactions create what scientists call positive feedback loops. It's more like A times B, where each event makes the next one exponentially more powerful. It just creates this vicious, self-reinforcing cycle of destruction. So, if these interactions are the recipe for disaster, you can think of climate change as the gasoline poured all over it. It just turns up the heat on the entire process, making everything more volatile and a lot more dangerous. And that is the critical question, isn't it? The research points to 2 main ways that our changing climate is taking a really bad situation and making it so much worse. It's kind of a 2-pronged attack. On one side, it just supercharges each individual threat. The droughts get hotter, the fires get bigger, the insect outbreaks spread further. But on the other side, and this is the really scary part, it also strengthens the dangerous synergy between them, making that whole domino effect we talked about even more powerful. And the scientists behind this are crystal clear. This isn't just some small adjusting. These supercharged interactions can be, and this is their word, transformative. That means they have the power to completely remake an entire ecosystem from the ground up. So what this all boils down to is that we're not just dealing with more of the same old problems. We are entering a brand new era of what some scientists are starting to call mega disturbances. These are events where the combined force is so much greater than the sum of its parts that it creates something we've literally never seen before. And this, of course, leads us to the most critical question of all. What happens when the damage from these compounded disasters is just too much? What happens when a forest simply can't bounce back? Think about it. Any complex system has a certain amount of resilience, right? A forest can recover from a fire or a drought, but these compounded, amplified interactions, they're pushing forests closer and closer to a breaking point, a tipping point, where there might be no coming back. And this right here is what's ultimately at stake. When a forest gets pushed past its tipping point, it can go through something called an ecosystem transition. This isn't just damage we're talking about, it's a fundamental and often permanent change. A forest can literally be replaced by a totally different system, like a grassland or a shrubland. And let's be absolutely clear here. This isn't about a forest just taking a few extra decades to grow back. This is about the forest as we know it in that place being gone, potentially for good, replaced by something else entirely. And the consequences of that loss, they're global. We lose all the biodiversity that lived there, we lose a critical natural system that stores carbon out of the atmosphere, and we lose the role that forests played in regulating our climate. The effects just ripple outwards.
So, after all this, what's the big takeaway? Where do we go from here?
The authors of this study basically frame it as a call to action. They're saying that even though we know for a fact that climate change is messing with these interactions, the whole area is still an understudied frontier in ecology. There is so much more we need to figure out, and we need to do it fast.
So for you and me, the takeaway is pretty simple. We have to update our thinking. We've got to move beyond just looking at single disasters in a vacuum and start seeing the world through a new lens, one that actually recognizes these hidden, complex, and incredibly important connections.
You know, this research really leaves us with a final and pretty sobering question. If these compounding disturbances can push an entire forest past its breaking point, what other ecosystems out there, coral reefs, the Arctic tundra, wetlands, are quietly creeping towards their own tipping points? It's a critical new way to think about the stability of the entire world around us.